I'm Joanna Wilson here for my OCR A-Level Chemistry Manual. Today we're going to be looking at Section 5 Core Organic Chemistry and we're focusing in on alkenes.
Just work, shoots are in.
The outcomes of today's session are to be able to understand alkenes are unsaturated, to describe how the double bond forms, explain the shape of the bonds in an alkene, discuss the concept of stereoisomerism, determine EZ cis-trans isomers from simple alkenes, give examples of addition reactions which alkenes can undergo, and discuss how polymers are formed from alkene structures. So there's a lot to go through on this topic. Alkenes contain at least one double bond, which means they are described as unsaturated since lots of molecules can be added to them. Now they have the general formula of CnH2n and the double bond is formed from sideways overlap of p orbitals on the carbon atoms. So as we know, carbon has p orbitals and those p orbitals are dumbbell shaped. Now these can interact between the carbon atoms, and the double bond, which is also known as a pi bond, forms from the sideways overlap of these orbitals above and below the plane of the bonded carbon atoms. It creates a high electron density around the bond, and we also still have the normal sigma bonds between the C and the CH's as well. So I think that's shown really well on the picture on the right hand side of this slide. Alkenes have a trigonal planar shape, which means that the bond angles are 120 degrees since the electrons are fighting to get away from each other. And it's similar to each carbon having 3 bonds, and there is restricted rotation to give the double bond in an alkene, which gives rise to some interesting properties. Isomerism we looked at a couple of videos back, and a stereoisomer is the same structural formula but a different arrangement of atoms in space, and we spoke about EZ isomerism and cis-trans isomerism. Now I would go back and watch that whole video, but what we need to be able to do is identify which isomer is which in the alkene. So how do we know if it's EZ or cis-trans? These few rules. So E isomer has the high priority groups on the opposite side of the double bond, Z has the high priority groups on the same side, and cis forms a C, whereas trans forms a Z. Now, how do we know which are the high priority groups? We must decide which of the groups has a higher importance, and a higher atomic number means that higher priority for the atoms bonded. So if you follow those simple rules for isomerism, you'll be absolutely fine. If we now move on to the reactivity of alkenes, alkenes are much more reactive than alkanes, and this is due to that region of high electron density in that double bond, which means that it can be very easily attacked. They're susceptible to attack by electrophiles, and the pi bond has a relatively low bond enthalpy as well, which means that it can be broken quite easily. Thank you so much for watching this teaser video for the OCR A-Level Chemistry Manual. You can now click the link down below to download the full manual. Please check it out now. Keep smashing it, and remember, anything is possible if you just work. Bye!